adding on the stuff I did yesterday. I don't think anyway. Let me check my list again, see if there's anything I forgot. Oh yeah, office hours. I think I forgot to mention office hours yesterday, real quick. Office hours, folks. Although again, obviously in the COVID environment, it's a little bit tricky to do office hours. But formally, office hours are 12:30 to 2 o'clock, Monday through Thursday. What that basically means for you guys is that I will be in my office that 2.5 hour period. Okay, so as far as actually, using them is a little bit tricky. Obviously, you can come by in person, although again, obviously masks are required. So if you do come by, you have to wear a mask. But probably the best way to deal with office hours is through email. Just email me, and I'll be around during that time to try to address emails and whatnot. As far as coming by to see me, I'm not going to say where my office is at this point because at some point in time in the next 2 weeks, and I don't know when, I'm changing offices. So no sense in telling y'all where an office is going to be when I'm simply going to move. Okay, so and I don't know when that's going to happen. So, and to be honest with you, I forgot what the number of the new office is going to be. So whenever I get around to that move actually happening, I'll let you know when the new office is going to be, so you can come by at that stage. Okay. All right. So at this point. Yeah, Josh. Yeah, I guess yeah, like for this class, it's not such a big issue. My other classes is more of an issue here. And I still didn't get a notification for that. Let me turn the sound up a little bit here. And that text came in. Let's see if that works. Yeah, if you want to come in person, I need to know. This class is not so much of an issue. I've still got some empty seats here, but I need to know just so I don't have too many people showing up, because if I have more people than seats, I will have to kick somebody out. Okay, and I don't want to have to do that. All right. So, yeah. So if you want to come in, you can send me an email. I'll take a look at it. As long as the numbers stay about what they are now, it's not going to be an issue. You should be able to attend any day that you wish to. All my other two classes, though, I'm having to make a schedule up, and not everybody's going to be able to attend as often as they want to. But yeah, if you want to come to class on a regular basis, you just got to go ahead and do that. So yeah, at this point, I guess I didn't send an email with this particular class because it wasn't an issue. Yeah, at this point, unless you hear otherwise, you can go ahead and start coming. If we reach a point where I hit capacity for the room, at that point, I will send you an email and say, don't come unless I tell you otherwise. Okay, but at this point, I don't anticipate that being an issue. But if it is, I'll let you know. Okay, but yeah, at this point, so tomorrow, Friday, unless you hear otherwise, go ahead and you can come if you'd like to. So yeah. I should have sent an email with you guys. I just wasn't thinking about it last night. So I was dealing with my other classes instead. Okay, so I guess at this point, let's go ahead. I hate to just jump into this, but we kind of have to jump in on this and get going on things. So remember, I'm going to do everything through OneNote here. So let me go ahead and get that set up to share here. So that's going to work. There it is. Good. Okay, let me get my screen organized here so I can see what's going on. Okay, now, again, just a quick little reminder again, folks, about how this is going to work again. Everything's through OneNote here. I'm going to write everything on here, and I get going here in a second anyway. Excuse me. Usually what I'm going to have in here, again, is all the stuff that I want to try to work. Now, problems, I'm inevitably am going to have problems in here, folks, that I can't work, okay? Just time won't allow me to work them. But pretty much everything in here, with the exception of a couple of these right here, which I know will get worked, are over on the website listed up here. Yep, okay? So there's the URL up there. Now, again, for the, I don't remember if it came up in this class or my Calc 1 class yesterday, but the URLs or the links I had up here didn't export properly, and they didn't work, and there's no way to make them work. So I have to put the URL in. I didn't fix the template up over on Blackboard just because it wasn't worth the hassle. Okay, so but when I get done with this, again, I'll export this and put it over there. You'll have the URLs over there. Or, of course, you've also got it here in the video here at this point. Okay, so we can go over here and check the problems I don't work, et cetera, et cetera. Oops, am I recording? No, I forgot to record. Thank you. Have to remind me to do that occasionally. Sorry about that. Yeah, I try to remember, but thank you. And I'm still not getting notifications for chats, and I don't know why. But, oh, well. Hope we'll catch them here. But thank you for the recording. Yeah. Okay, so I guess let's go ahead and get started here. Get the mouse out of the way. Don't need that anymore. So integration. Okay. Now, as I mentioned yesterday, folks, right at the end of class, I think it was, we are basically jumping straight into integration, whether we like it or not. Okay, so we have to be able to do our basic integration skills. And again, as I commented on yesterday, I'm not going to do a lot of review and get you back in the swing of things. I'm assuming you know integration at this stage. Okay, so make sure you can do your basic integration skills. Now, having said that, I will do a little bit of review on occasion just to kind of get us back in the swing of things. But to be honest with you, more often than not, as is the case with the stuff that we're doing here, it's more designed to lead us into why we're doing the stuff that we're doing. Okay, so we can do some review, but it's really more designed to get us going on things. All right, so let's kind of start off with this first one here. So first one there. Sorry about that, didn't mean to write on there. But the first one here, integral of e to the x. So again, remember what integration is, yeah? Integration is just asking, basically, what did we, sorry, no, right, there it is. What did we differentiate, right here, yeah, to give us the stuff that's inside of our integral, yeah? So I always consider e to the x to be the simplest function in the world to integrate because, again, what did we differentiate to get e to the x? Well, e to the x, yeah. Okay, so simplest function in the world to integrate. So, oops, sorry about that. Sorry. In first, then hand. E to the x, yeah. Okay, so integral of e to the x is straight up e to the x. Now, don't forget though, this is going to be important for us, that we always have to remember we have that constant of integration that has to be there. Yeah. Okay. Because remember, it's what did we differentiate to get, and there's always a possibility that there was a constant sitting there that would differentiate to 0. Yeah. So don't forget your constant of integration. Okay. All right. So just remember again what integration is asking us to do. What did we differentiate to get? Yeah. The stuff that's inside there. Okay. Now, move on to something a little bit more complicated here. As I mentioned yesterday as well, again, folks, the thing you really need to be good at is your use substitutions because they are going to be all over the place. So you've got to be able to do use substitutions. Okay, now, in some cases, like in the case of this one here, if you're really good at kind of doing use substitutions in your head, leave yourself some space here. I'll fill in a line here. You can kind of eyeball this one. So that's going to be, oops, sorry, 6 e to the, oops, darn it. Still getting my new system down here. Sorry about that. So again, if you get good at the point where you can do some of these substitutions in your head, great, there it is. So the integral of e to the 6x is just 1/6 e to the 6x, and of course our plus c. And again, of course, we can always check that real quick if we want to. Yeah, simply by doing a quick little chain rule derivative here. And we pick up a 6 for the chain rule, cancels the 1/6, gets us back to the what we had there. Yep. We can check if we wanted to. So if you're good at doing these in your head, great. If not, remember your basic u substitution stuff. Since all we know how to technically integrate is e to the x or e to the u or whatever letter I want to use, we don't have that here, yeah? We can always just say, okay, I'll let u be 6x, yeah? Except, there it is. And then again, remember, then this just becomes, just have a little bit of space in front of that. That just becomes e to the u, yeah? 6x being u here. Remembering as well the idea, and this is going to be really important in a couple of sections, folks. It's something that a lot of folks kind of in Calc 1, they don't pay attention to because it wasn't that big of a deal. It's going to be super important in a couple of sections for what stuff we're doing here. Remember with your substitutions, folks, the idea is you need to substitute every x over into here. And by every x, I mean every x. I mean including the dx there. Yeah, okay? That dx needs to get substituted into u's in some way, shape, form, or another. And again, remember, for basic use substitutions, that isn't hard. All you have to do is remember that differential stuff, yeah? So take our differential for this thing. So du, differential for that. Remember how those work. It's just differentiate this. So just 6, there's 6x, of course, is 6, and then just tap a dx onto it, yeah? So basic substitution stuff there, or basic differential stuff there. And say to myself, okay, I've got this dx I've got sitting over here. Well, hey, guess what? Again, I've got dx sitting right there as well. Yep, okay. So all I have to do now is say, okay, if I just solve this for dx, divide by 6 and multiply by a 1/6, yeah, oops. Dx then is just 1/6 du. Yeah, so I come over here, I can either put the 1/6 du here, or that 1/6 is a multiplicative coefficient, so I usually factor them out just to get them out of the way. Oops, right, and then du. Yep. Okay, so basic substitution stuff here. Yeah, so there's your basic substitution. Here's the differential work, gets rid of the dx here. At that point, we can just integrate. Integral of e to the u is e to the u, but u is a 6x, so e to the u or e to the 6x, and there's my 1/6. Yep, yep. All right. Does that make sense to everybody? Everybody kind of remember doing basic substitutions, I hope? Yeah, good. Okay. All right. Let's do one more substitution here just to say why not. Let's do one more substitution. Okay, so a little bit more complicated this time. So integral x e to the x squared here. So again, if you're really good at this stuff, folks, you know this is going to be a 1/2 e to the x squared plus c. Okay, so there it is. Now, again, if you're not getting good at doing these in your head, although I would suggest, folks, at some level, for this one and this one, get to the point where you can do those two in your head. Okay, it'll make life a lot simpler for everybody, or not for everybody, for you. Okay, if you have to sit down and do all the u substitution stuff for every problem, you're going to find these problems take forever. Oh, they take forever anyway. Right, so you don't want to be doing all the u substitutes. If you can do some of this quick stuff in your head, life will be a lot better for you guys. Okay, all right, but let's go ahead and do it anyway. So again, I've got this x squared here, and that's not something we don't want to see again. We just want to see just an x or just a u or whatever we've got there. Yeah. So say, okay, I want to kind of make that go away. So we'll do u equals x squared. Yeah. And then again, I've got e to the u sitting here, spiffy. But again, what we've got left over here again is I've got that x times dx sitting there left over that I need to substitute away again. Well, again, in this case, we can use our differential again. So du integral of x squared, yeah, is 2x dx. Okay. Now, unlike or somewhat up here, of course, I've got this 6 up here I didn't want to have. Well, here I don't want to have the 2. I see an x times dx. That's, again, what I want to get rid of. Yeah. Okay. So if we, again, just solve, this is the way I choose to do this. There's a couple of ways to do these, but this is the way I do them. X times dx is just 1/2 du. Yeah. So come back over here then. X times dx, well, that's my 1/2 du. So again, I'm going to factor the 1/2 out. Yeah. Slip my du in there, and then e to the x squared, but that's just e to the u. Yeah. Okay. So quote unquote simple, quote unquote. I realize say that may not be if you don't remember how to do these, but there it is. At this point, again, this is an integral we can do. So I got my 1/2. Again, integral of e to the u is just e to the u. I'm not going to bother writing that down again because we know that u is just x squared. So e to the x squared, and they're ever-present constants of integration. Yeah. Okay. So does that make sense to everybody? Yeah. Everybody follow? Okay. Now that is kind of our basic. Excuse me. There's our basic u substitution. Again, this is real basic stuff. We're going to get a lot more complicated, of course, down the road, and we'll see a lot more complicated ones as well. But basic u substitutions. The point I want to make here with this, I don't want to get too far into this. Sorry. Is this problem right here? Okay. The temptation for this problem here, folks, is to try u substitution. And we could try. So I'm not going to go through the work here. You might want to try to see if you can get this. But we'd say, okay, well, just like we did up here with this one, hey, it's 6x up here. Let u be 6x there. Fine, let's do it here. The problem, though, again, is I've got this extra x sitting there floating around that, unlike the last one, I don't have. Now, again, of course, you can fix that up saying, oh, I can divide by 6. X is just a 1/6u. So I'll let you guys go through and check the work if you want to on this one. If you go through and do all the work on this, folks, excuse me again, what you're going to end up with yeah. So the 1/6 e to the 6x up here. So you're talking about this one. Yeah. So that's just that one up there. Yeah. Oops. But this one's not going to be that. So I'll let you guys go through and check the work on this. What you end up with is a 1/36 u e to the u du. Okay. You pick up a 1/6 from the x here. That's just a 1/6u. You pick up another 1/6 from difference again. There's the 1/36. But to notice, though, folks, again, kind of highlight the whole thing here. That thing there is not substantially different from that thing there. Okay. In fact, as far as we're concerned, they're essentially the same thing. Okay. So in this particular case, doing a u substitution is completely useless to us. Okay. All it does is change the letters. That's it. Right. Nothing more, nothing less. Okay. So at this point, that's what you need to be aware of. So that's what we're going to start off with now. Right. So How do we do this problem? Because this is a problem I do want to do, and we'll do this by the end of the day. How do we do it? Well, to do that, we need to derive up a formula. Okay, so let me start off here with something really, really basic that you all should know. Okay, I'm going to get lazy here, folks. F of x, g of x. I'm going to put the of x's in. Okay, just make life a little bit easier for us for writing, etc., etc. Product rule. You know what the product rule is, yeah? So the product of f times g. Well, derivative first, so f prime times second one left alone, so g, plus first one left alone times derivative second one. Product rule. You all know what that is. Hopefully, anyway, at this stage, yeah? Okay, now, I realized that starting off with product rules seem to have nothing to do with what we're doing here. That's fine. Okay? Don't worry about that. And we'll see where this is going here in a second. Now, the next thing I want to do is just because I want to do this for no reason, I want to integrate both sides. So if I integrate this side, so integrate fg prime dx, and remember there's technically of x is on those, so I'm getting lazy on those. Over here, integrate both sides here. So technically an integral in front of this thing, but I can split it up into plus, yeah. So integral fg prime dx plus integral fg prime dx, yeah. Okay. Now, again, I realize this doesn't appear to be going anywhere. Bear with me on this, okay? See where this is going here in a little bit. Now, remember what we did clear up here with this e to the x business, yeah? This, again, folks, was not here really to remind you of integration, it was how to do integration. It was reminding you, again, of what integration is asking us to do, yeah? What did we differentiate to get? That's what's asking us to do. Now, these two here, this one, so again, this one, and this one. Yep. Okay. I can't do anything with those, but I can do something with this one. Okay. Because what are we doing here? What's this integral here asking us to do? It's asking us, what did I differentiate to get the derivative of f times g? So what did we differentiate to get the derivative of f times g? It's a trick question. Anybody want to tell me? What did we differentiate to get the derivative of f times g? How about, whoops, f times g. Yep, sorry about that. Highlighted there. Yeah, good, Tyler, good. Yeah, I'm in class here as well. So f times g. That's what we differentiated to get the derivative of f times g. Yep. Okay. So this is an integral here I can do. Can't do this one because the derivative's only on one. So I can't do those two. Okay. But I can do this one. Now, technically, what else should go here? Technically, I should do a plus c because we just did an indefinite integral. Right. So technically, a plus c. We're going to hold off. We're going to take care of that plus c down the road. Right. But technically, a plus c. Now, this thing here, I guess let's write this back down again. It's the same thing. So this side's not going to change. Okay, there we go. Now, for no reason whatsoever, okay, no reason whatsoever, I want to solve for that integral right there. Okay, I'm not going to worry about that quite yet. Okay, so if I solve this integral right there, well, technically all I need to do then is take this integral here and subtract it over to this side. Yep. So integral of f g prime dx is equal to f times g minus, because I'm subtracting this integral off, minus integral of f prime g dx. Okay. So all I've done is manipulation. Start off with the product rule, did some integrals, one I could actually do, okay, and a little bit of basically algebraic manipulation, and I got to this stage here. Yeah, everybody follow what I did there. Note we're boxing that off. Okay, this is technically, note I said technically, the integration by parts formula. Okay, now I'll talk more about this formula here in a minute, folks, but I want to come back and address the idea that I said technically that's the integration by parts formula. Yep, okay, which probably means maybe that's not the one we're going to use, and it's not the one we're going to use, okay? This is technically the correct integration by parts formula. What I'm going to do is change things up a little bit because I'm going to make life easier on me, okay? So what I'm going to do is a u substitution. Okay, I'm going to let u be f of x. I'll put the of x in here, so remind there's an x in here. Technically, again, f of x, g prime of x, f of x, g of x, etc., etc. Yeah. Although, you know what, though? I'm going to do something you've never seen before. I'm not going to do one substitution. I'm going to do two. I'm going to let u be f of x. I'm going to let v be g of x. This is a perfectly legitimate thing to do, folks. Right? I guess you probably never saw this in Calc 1. Who cares? It's legitimate. Okay? Nothing wrong with doing this. Okay? It works the same way. If I've got the u here, I'm going to need to compute my du. Okay, that's easy enough. Just differentiate f. Well, I can't do that, but I can write notation for it. Yep. So f prime dx. Same thing with the v. I want to get my differential. So dv. That's going to be then g prime. Again, I can't do anything with that. I can write notation down for it. That's it. And then dx. Yep. Okay. Now, come back up to our formula up here again. Right. So I got my green box up here. Okay. So just look at my formula. What do I have? Well, I see an f here. Again, technically that's f of x. Didn't write the of x in, but I see an f here. Well, that's not an f. What's that? That's u. Okay? Because I've substituted f of x to be u. So that's not f. That's u. I'll write this down here in a minute. That's u. And then what's left over here? What's left over right there is g prime times dx. Yeah? Oh, what's g prime times dx? Well, g prime times dx is simply dv. Yeah, okay. So I can take this first integral here and write it not as integral of f g prime dx, but integral of u dv. Okay, we'll write that down here in a second. Okay. Off to this side then. F of x times g of x. Oh, that's easy. That's u times v. That's all that is. Okay. This integral here, same thing here. Although maybe what we want to do with this integral here is rewrite it just a little bit. Oops, sorry. Integral, just rearrange things a little bit. G f prime dx, just to make it a little bit more obvious. Yep, same thing, just flip the order on the f prime and the g there. Yep, same thing with my first integral. What's g? Oh, well, g is just v. Yep. So I can replace this g here or here, whichever way you want to do it, with a v. Oh, and what's f prime times d? Oops, sorry, not du. Sorry about that. Dx. Sorry about that. Dx. There we go. F prime times dx. What's that? Oh, well, that's just simply du. Okay? So I can take the second integral over here then and write this as integral of v du. Or, so I'm not going to write this down. There's a case where I got way too much space in here. There we go, folks. There is our formal, I shouldn't say formal. Here is the integration by parts formula that we're going to use. Okay? So integral of u dv equals uv minus integral of v du. Okay? So again, let's make this clear. That's the formula that we're going to use. Okay? So don't worry about the one that we've got up here I boxed up in green. We're never going to use that one. Okay? The one we're always going to use, again, go down here, is this one right here. Okay? Now, here's the thing, folks. Okay? I want you to notice something with this formula here. What this formula doesn't do is it doesn't actually integrate anything, folks. Okay? All this formula does, it takes an integral that I don't know how to do, the u dv, and it writes it in terms of another integral, v du. That's it, folks. This formula does no actual integration. It just rearranges integrals a little bit, rewrites it in a different form. That's it. The hope is, though, is that while I can't do the integral of u dv, the hope is that we can do the integral of v du. Okay? So there's how this formula technically is going to work. It doesn't do an integral. It writes one integral in terms of a second one. Hopefully, we can do the second integral. Right? Now, next problem with integration by parts. And let me kind of highlight this again. Okay, that's the integral I'm trying to do. Okay? I have to be able to take the integral I'm trying to do and relate it to the integral I actually want to do. Yeah. Okay. In the sense of I need to make this thing look like the integral of u dv. What that means for us, folks, and this is the part that gets folks in trouble with this stuff here, and I get that. This is something you're going to have to get good at doing, is you're going to have to figure out what part of this integral down here is the u, what part of the integral down here is the dv. Okay? And there are no hard and fast rules here, folks. This is something I'm going to have to make really clear to you guys at this point. At some point with this stuff, you're going to think you see patterns. Trust me, I will break those patterns at some point. Okay? You're going to see patterns. You're going to want to do the patterns. I will break them. Okay? And there's at least one. Actually, I think there's two on the homework that break the pattern that you think you're going to see. Okay? So be aware of this fact. Okay? Now, here's what we have to do again. So I've got to say, okay, I want to figure out what my u is. I'm going to need to figure out, I'm just kind of do them like this. So you just put my u sitting here, put my dv over here. I need to figure out what part of this is u and what part of this is going to be dv, okay? And keeping in mind again that what we want to do is take the integral here that I can't do and write it in terms of one that I can do. Okay, now let me scroll back up here for a second. Yep, all the way back up here to this one. Yep. If I try this sudden, be careful with my U's here, folks. There's only so many letters in the alphabet, so we only can do so many. Yep. Okay, so the U's mean two different things here. U substitution up here, and then the U's and the V's for the integration by parts down below. Yep. Okay. Yeah. Point is if I just do a straight up U substitution, I don't get anything substantially different. It's basically the same thing. And the real problem here, folks, at some level, in this x times e to the 6x is that x sitting there. Okay. If I didn't have the x there, it would be dead simple to do, just e to the 6x. We did that one up above. If I didn't have e to the 6x, it'd be dead simple. We just have an x. Okay. That's one. I'm not going to do that one for y'all because I'm confident y'all could do that one. Notice as well, not important for us here, but if I had 6x squared here, I could do the same thing I did up for this one. Yeah. Okay. But again, I don't have an x squared there. No easy way to get an x squared there. But note that. Now, let's keep in mind though what we said here in a second. So what I said was if I didn't have the x, I could do it. If I didn't have the e to the 6x, I could do it. Well, let's assume that I picked my u and my dv here for a second. Yep. Okay. So that means then, go back to my formula. There it is. U and V, well, I know what my U is. dV, oh, that's not over here at all. Yeah. My formula over here only involves the U. I need to figure out what's V. I need to figure out what du is, and the V here as well, of course. The du is simple. Yeah. To get my du, what do? You simply differentiate. Yeah. Differentiate, tack on a dx. Right? That's easy to do. Okay. How do we find our V? Well, that's actually simple as well. If you think about it again, how'd you do the du? To get the du, what'd you do? You differentiated the u. Yeah. So that means to get the v, what do? Well, you integrate dv. Okay. So pick your u, differentiate it to get the du. Pick your dv, integrate that to get the v. Okay. Now, how does that help me or help us? However you want to say it. Well, again, keep in mind what I wanted to do. Yeah. I wanted to say to myself, if I could figure out a way to get rid of one of those two terms, maybe life would be not so bad for me. So let's just do it the wrong way first, just to show you what happens here. Let me just put let's put the e to the 6x there on the u, okay? Just because why not? I'm going to try that, see what happens, okay? And then put the x over there on the dv, okay? Notice again what I did. I picked the u to be e to the 6x. Don't worry about why I picked that. It's wrong. I'm not going to worry about why I picked it, okay? And then everything else, I got my dx, everything else has to go over on the dv. And usually we're going to pick the u's first, not always. Usually pick the u's first, dv's everything else, okay? But not always. Now, at this point, we've got an issue. Because again, differentiating u, well, that's just 6e to the 6x. And tack a dx on as well, I guess. Yeah, well, that didn't get rid of the e to the 6x. That's not going to do me any good. Integral of v, so integral of x dx, well, that's just a 1/2, oops, sorry, 1/2 x, sorry about that. 1/2 x squared. Yeah, not only did I not get rid of the x, I made it worse by making it squared. Yeah, okay. Remember what I said I want to do? I would like to try to get rid of one of these two. Now, I most definitely did not get rid of either of those two, did I? Right? Kept the exponential around and made the x worse by tacking an x squared onto this whole thing. Yeah. Okay. So what's that mean for me? That means it's wrong. Okay. Because when I go to plug this stuff in, I'm going to still have x's over here. I'm still going to have e to the x's over here. This ain't going to work for me. Okay. So I can't do this one. So, and it's going to happen for you sometimes, folks. Sometimes you're going to guess wrong. It happens. Okay. So you realize when you plug in, oh, geez, I can't do anything with this. So try something else. So let's try something else. So u dv. Okay. Now, again, would like, keep my formula in play here for a second. Again, I would like to try to again pick these things so that maybe I can make one of these two terms go away. Well, one thing I know about exponentials is it don't go away, right? There is exponentials or exponentials, integrals of exponentials are exponentials. They do not go away ever under any circumstance. Okay, these through basic calculus processes, right? But what do I know about x's? Well, if I integrate it, it don't go away. But if I differentiate it, what happens to it? It goes away. Yeah, good. Okay, so let's try that, and then let's make the e to the 6x dx then part of our dv. Yep. Okay, so du then, dead simple. Integral of x is 1, not going to bother writing that up. Dx, there it is. V, again, I'll write this down. I'm never going to write this in. I shouldn't say never. I will almost never write this integral down, folks. If you need to write it down, go ahead and do it. But usually this is ones we're going to kind of do in our head. Okay? So integral of e to the 6x dx. We did this up above, which again, by the way, folks, is why I did that one up above, is so I wouldn't have to do it here. Yeah. Okay. So at this point, 1/6 e to the 6x. Again, don't bother with the plus c. Take care of that plus c here in a little bit. Okay. Much like an x. There we go. Okay. At this point, folks, these v integrals here are usually going to be fairly simple integrations you can do in your head. Okay? This is where, again, you want to get good at quick little use substitutions to make life easy for you. Okay. All right. Let's see what my formula gives us now. So I'm going to have to scroll up here and lose my formula here a little bit, unfortunately. But so integral x e to the 6x dx. Here's the integral we want to do. Well, what's my formula? It's u times v. All right, so x times 1/6 e to the 6x. Let me kind of rearrange the order a little bit here. So 1/6x e to the 6x. All right, minus, and folks, I cannot stress this enough. Let me make that really big and bold there. Don't lose track of that minus sign. That gets folks in trouble. I can't begin to think how many times that gets people in trouble. Watch your minus sign there. Yep. Integral, here for a second, of v du. Yep. So integral of v times du. So 1/6 e to the 6x dx. Okay. That 1/6 again, folks, it's a multiplicative constant. We factor that out again. I'm usually going to factor that out because it's usually not useful inside the integral. If you want to leave it in, you surely can, but I usually factor it out. Okay. All right. So 1/6 integral of e to the 6x. Simple use of my formula. Yep. Do y'all agree with my ability to basically use a formula? I hope. Yep. Okay, good. Now, did I get it right? In that sense of, did I pick my u's and dv's up here correctly? Well, again, I haven't done any integration yet. But again, the idea was to take our first integral there and hopefully write it in terms of one over here that we can do. Okay, so the real question then is can I do this integral right here? And the answer to that is unequivocally yes. Why? Well, because we've done it twice now. I did it here for the v, and I did it one up above at the start of the class. Yep. Okay. So at least in this particular case, this integral is one that we can absolutely do. Okay. Is everybody getting connection timeout? Or is that just me, or just Jordan? Everybody all right? No. Okay. Just one person. Okay. That happens occasionally, unfortunately. Sorry. Sorry about that. Okay. So yeah, it happens, unfortunately. Sorry about that. Okay. So let's kind of finish this out real quickly here. All right. So got the term here in front. Let's not forget that. Easy to forget about that sometimes. Yep, there it is. Minus, okay, what do we got? I've got a 1/6 sitting here already. I'm going to pick up another 1/6 for my integration. Yeah, so 1/6 times 1/6, so 36. Yep, and then e to the 6x. So, everybody agree with my quick integration skills there? What part? 36. Yeah, I've got the 1/6 sitting here. Yeah, it's already here. Okay, and we did this integral here sitting up here, right? And that integral here is going to pick up another 1/6. So I got the 1/6 here times that 1/6 there, so 136. This is going to be the problem with, I'll do a lot of this stuff in my head, folks, and it's something, again, that you're going to want to get good at doing in your head as well, again, just because it makes these things go a heck of a lot quicker sometimes, okay? So, but if you have to take your time doing this, nothing wrong with doing that either, okay? All right. More like a 6 there. All right, now, at this point, let's notice what we've got over here on this side. Over here on this side, we have no more integrals. Yep, oops, I'm sorry.
The formula that we made.
Yeah. So this one, in the blue box here?
Yeah. Yeah. So that highlighted side, that's the side.
Yes, the highlighted is the original. And the stuff will, yes, this is the problem. The highlighted is the problem I give you. This is the stuff you will hope you can figure out how to do that. Yeah. Good. Okay, but back to my point before I forget here, folks. Let's see if any more questions then. Once you see no more integrals over here on the right side, now we tap the plus C. That's when it shows up. Okay, when you're all done with the integrals, no more integrals on the right side, plus C shows up over there. Okay. All right, so everybody follow with this one, because the rest is probably going to go a lot quicker because I'm not going to have to do quite much discussion on the rest of the problem. Yeah. Online, you guys doing okay? I hope. Good. Okay. Now, likewise, folks, if you wanted to, you could check again by doing a derivative of the right side and get this stuff over here like I did the first part of the stuff. Have fun doing the derivatives, folks. Okay. They're going to be really rough doing the derivatives for these most of the time. Right. So check if you want to. Just expect the fact it'll probably take you longer to check than it did do the problem itself. Okay. But check if you want to. But there it is. Okay. So let's make that curve then. Highlight that real quick. There is our answer for this problem. Yeah. Okay. So let's work another problem. I can scroll down here. Yeah. Again, making myself too much space there. That's okay. Yeah. Forgot about this. Okay, real quick, folks. I am not going to do a lot of definite integrals in class because remember, definite integrals are really fairly simple for the most part. If you can do the indefinite, you can do the definite. So we'll do one here. We'll do one or two more in a couple sections, but for the most part, not doing a lot of definite integrals. You will definitely see them on the homework though. Okay? Because again, it's basically if you can do the indefinite, you can do the definite. Yep. Okay. Remember how that works. Yep. So definite integral here. So let's do this one real quick. Minus 1 to 2. Same integral I did up above, so I can kind of reuse my work from up there. Okay. So remember how these work again. Yeah. Sometimes let me erase the limits here for a second. Technically, what do we do for indefinite? So I'm doing my definite integral. Yeah. Technically, what do we do? The first thing we do is we do the indefinite integral. Okay. So and we just got done doing that. Yeah, probably. Yeah, can't scroll up right now. Let me get to my notes real quick. I got sitting next to me. So we did the indefinite a minute ago. So I'm not going to scroll back up here. So it was a 1/6 x e to the 6x minus a 1/36 e to the 6x. Technically plus c, but we're not going to write that up. Okay. So we do the indefinite, and then we come back and say, but I didn't have an indefinite. I had definite. I had my limits. Yep. Okay. So at that point, we say, okay, I'll put my limits on here then, which is again why we don't do the plus c. Oops, sorry about that. Screen is no, sorry about that. Oops, finger didn't want to work there. All right, now at this point, this is a little bit messy here at this point, folks. But remember how this works. You evaluate at your upper limit. So let me move the equal sign over here, make it a little bit easier for me. So 1/6, yeah, we can do that in our head. 1/6 times 2, that's a 1/3, yeah. So 1/3 e to the 12 minus a 1/36 e to the 12. Okay. And then minus evaluated our lower limit. So minus, there's so minus another minus 1/6 there. E to the minus 6 and minus 1/36 e to the minus 6. Yep. So evaluate at your upper limit minus evaluate at your lower limit. Yep. Yeah, good. Now that's the thing I didn't put in here. I want you to be careful, folks. Okay. So I'm gonna put something in here, then promptly erase it. But you're tempted to say, minus minus, so those two just cancel and become pluses. Yeah. Except Santiago, right? The original last semester. Good. As Santiago pointed out, though, it has to be subtract off the evaluation to the lower side. You have to have parentheses. Okay. So watch your parentheses. So evaluate color here. Evaluate at your upper, then evaluate at your lower, and then again subtract the two. Yep. Okay. But watch your parentheses on this. Okay. It's one of the bigger mistakes folks make with this. Okay. So, all right. Everybody kind of follow my evaluation, and I'll let you guys check my quick arithmetic here. So, some quick arithmetic, you will get 11 over 36 e to the 12 plus 7 over 36 e to the minus 6. And there we go. 7 over 36, yeah. Okay, quick little reminder of definite integrals. I remember how to do those, I hope. Okay. Now, sorry, I'm losing track of my time. Yeah, good. Okay. Quick little comment about web assigned for homework, folks. Okay. Yesterday I talked about decimals and whatnot. Pay attention to the problems. If the problem does not reference number of decimals, it doesn't want decimals, it wants exact answers. Okay? So if it doesn't reference decimals, it wants exact. Sometimes it'll mention exact, more often though it won't. Okay? Now, I bring that up because in this class, if we're doing a definite integral, it inevitably wants exact answers, meaning you have to type in that thing right there. Type in the decimal for that thing. Right? So be careful. Yeah, no, because and that's the thing. Remember, for definite, we don't have plus C. Yep, it's just straight up a number, which is also again why I didn't put the plus C up here, because it would have been a plus C here, plus C here. They subtract off, go down to C. Yeah. So they would drop out. Yeah, so no plus C here. And yeah, if you do put a plus C on definite for website, it'll definitely yell at you about that kind of thing. So yeah, but again, just be careful, folks. And remember, I know it's just painful to type this type of thing in sometimes, but you got to. Okay? So WebAssign's going to want the exact. The screen. Okay, so let's work another problem. We've got about 20 minutes here. I think we can work another problem, maybe think about another one as well. So, all right, another problem, a little bit more complicated this time, but actually not that complicated. Okay, so again, if I didn't have the 3t here, this would be dead simple. 5 times cosine. Hey, we could do that. That's just straight up use substitution. We could do that. Okay. If I didn't have the 5 and I had a t squared in there inside the cosine, I could do it because a quick little use substitution again. Right? So basically, if I didn't have either one of those, one with a small change up here, I could do it. If I didn't have the cosine at all, again, I could do it. Okay, so that's something we could do. Now, that means again, I got to figure out what's my u, oops, room there, and what's my dv. Okay, so what's u, what's dv? Now, again, being careful with patterns, because I'm going to say this for the first couple of problems, and then I'm probably going to get myself in trouble because I kept saying. Okay, so I said for the first problem, I'd like to try to get rid of one of these two pieces. Okay, and that will work most of the time. It will work here to help you figure out what you need to pick for your U's and your DV's. But again, watch patterns. I can break these things so that that's not how you want to do these. Okay, so watch falling into patterns. Okay, but same ideas at this point. Think about that to start things off with here. Okay, so ask myself through the process, you differentiate, dv, integrate. Can I make one of these two things go away? Well, much like with exponentials, I can't make the cosine go away. Well, I should be careful. I can make the cosine go away. I can turn it into a sine, but I can't make the trig function go away. Yep. Okay. If we differentiate cosine, we're going to pick up a sine. If we integrate cosine, we're going to pick up a sine. Okay. Well, actually, minus sign on the different derivative. Yeah, but basically, change cosine into a sine, change cosine into a sine. Yeah, that term ain't going away, right? Likewise, if I integrate, say, that first term there, again, pick up a t squared, pick up a t on the 5, I'm putting more t's in, making them go away. Yeah. But much like with the first problem, if I put that first term, sorry, my t's and s plus are going to look way too similar there. Scroll this down a little bit. Something again, sorry about that. If I put the 3t plus a 5 there on the u, when I differentiate, the 5 drops out completely, and hey, guess what? So does the t. Yep, okay. So this looks like that's going to work out real nicely for me for the u. Okay, that means we're going to put everything else onto the dv. So cosine t over 4 dt. And now, one more time here, let me write the integral up here, folks. Again, usually I'm not going to write this. You're not required to write it as well. Just mostly remind us what's going on here with this. Okay, so there's my integral. Now, at this point, folks, I am going to start doing these U substitutions in my head just for time issues. We don't have time to do every U substitution here in class. Okay, so well, I should be careful as well, folks. When I say U substitutions, I don't really mean U substitutions anymore. We already have U's floating around here, something else. Yes. Okay. At this point, I would do. I would do a substitution, but I'll call it W. I would do a substitution t over 4. Yeah. Okay, now I'm not going to actually do it. Okay, and in fact, this is the last time I'm going to actually write the substitution down as well. Okay, so if you're not sure how this substitution works, folks, at the end of class here, go home, do substitution, make sure you get what I get. Okay, so again, I still have time to do all these in class. It would take us 4 days to get through this lecture if I did every substitution. Okay, so I can't do that, so I'm not going to. But in this case, we'll pick up a 4 from my substitution. We differentiate cosines minus sine. That means integral of cosine is a plus sign. Yeah. Watch plus minus signs when you're dealing with the cosine. Yep. Okay. People love to screw those things up. Okay. So be careful with that. And then t over 4. And there we go. Okay. So there's my d. There's my v. Yeah. Okay. Now let's do our integral. So integral 3t plus 5 cosine t over 4 dt. All right. So what do we got here? So it's u times v, so 3t plus 5 times all this stuff down here. So move the 4 in the front, make it a little bit easier to write. So 4 times 3t plus 5. My t's and my 5s, or my t's and my 4 plus are always going to look like they're, sorry about that. Real quick before I write the rest of it down, folks, the 4 here, leave it out in front, distribute through if you want. I don't care, right? Web assign ain't going to care either. Right, so if you want to write it like this, you can, or 12t plus 20, be my guest. Just watch your parentheses because what comes next is sine. Yep. Okay, so sine t over 4. Let's go a little bit now. And then minus, oops, here, this. So minus, so there's my u times v, yeah, minus integral of v times du. Yeah. Right, so what do we got here? So 4 times sine times a 3, so 4 times, oh, sorry, yeah, 4 times 3, 12. Come on. So 12, I'm going to factor that out to make life easier on me. And then sine t over 4 dt. Yeah. Yeah. Move things down this way a little bit. Okay. Everybody kind of agree with my ability to plug into the formula. Basically what I've just done. Yeah. Okay. Let's see what we got here. So equals this stuff. Write that back down again. T over 4. Okay. Now, again, ask myself, can I do this? Yes or no? Well, if I can integrate cosine by itself with a little bit of a substitution, I can integrate sine by itself. Yeah. Okay. So again, same substitution for this integral. Yeah, t over 4. So I'm going to pick up another 4 for my substitution, just like I did up here. I got my 12 sitting here. Times the 4 I pick up there. So minus 48. Now, again, watching plus minus signs. Yep. Derivative of sine plus cosine, integral of sine minus cosine. Yeah. Again, watch your plus minus sign. So minus minus a plus sine t over 4. So did I pick u's and v's correct up here? Well, sure, you did them correct up here because I could do that integral sitting right there. Yeah. This one right. Right. Always do it so yeah. Okay. So, everybody follow so far? Yeah. Okay. What am I missing? Somebody help me out. Plus C. Good. Yeah. Good. So watch your plus C on these things. Yeah. These problems take time to do. It is really easy to get to the end and get the plus C. Yep. Just one at the end. Yeah. That's all you ever do. When your integrals are done, you see no more integrals on the right side. Back to plus C on here. Yeah. Good. You could if you want to. I don't care. I don't care. And like I said, WebAssign's not going to care either. So my rule of thumb is does it simplify writing? Yes or no? It simplifies writing. I'll distribute it through. So in other words, if this had been say a 1/2 and all these had been even, oh yeah, I'll distribute it through any day because it'll simplify. Right. In this case, 12, a 4, a 3, and a 5 versus a 12 and a 15. Yeah, up to you, which is easier. Right? Yeah. And like I said, and WebAssign will definitely not care. So don't worry too much about it. I just kind of rule of thumb what you want. Okay. Anything else with this one? Simple problem? Yeah. A lot quicker this time, obviously. Oh, Oh, I'm sorry. I'm sorry. Oh, yeah, cosine. I apologize. I apologize. I apologize. Yeah, I'm sorry. Just not paying attention. I don't know why my notifying. Sometimes it beeps and sometimes it doesn't. I'm sorry, folks. I'll listen for the beeps. They don't always come in. Um, yeah, I apologize, folks. Catch that. That should have been a cosine there. I apologize. Um, this also, of course, brings up the next thing here. Didn't do this intentionally here. Um, pay attention. Yeah, don't get in a hurry like I did and write the wrong thing down. Too easy to do. Yep. Okay. So I apologize. And if you guys catch me making a silly mistake like that, please holler. Okay. I do not have a problem with you guys pointing out that I made a mistake. And if someone catches a comment I missed, please holler as well. Okay. So questions now, or any other questions other than the one that I missed? Okay. So 10 minutes here, folks. I think I can do another problem here. So let me go ahead and do at least think about another problem here. It's a little bit longer problem in this case. Okay. Now, same basic idea. I've got myself kind of a polynomial here and a trig function here. Again, I'm going to make this comment about patterns one more time here, folks, because by the end of this problem, you're going to see a pattern. You're going to want to do it every time. I will promptly break it in the next exam. Okay? So again, I can break your patterns. If you think you see them, I will break them. Okay? And again, you've got a couple on the homework that break them even harder. Okay? So be careful with that. Yep. Okay? All right. Now, in this case, though, it makes some sense maybe to try same thing we've been doing to this point. Again, yeah, pattern, but watch out for it. So let's let u be a w squared here. And then, and this let dv then be our sine. Yeah. So sine of 10w. Okay. All right. Now, du, simple enough again, 2w dw. V, again, simple enough. I'll pick up a 1/10 in my substitution. Yes, again, my substitution have to be a 10w there. So I'll pick up a 1/10. Right, there it is. Get my integrals right this time. Cosine 10w. Take the minus sign out, so I'm integrating sine. Yep. Again, did not bother to write the integral down. Yep. And I'm not going to do that more often than not. Okay. All right. Now, this looks like this may be an issue. Let's see what I mean by that. Okay, so let's start my integral. I'm going to come over here, get myself room to write all this up. So, integral of w squared sine 10w. Okay, so what do we got? So integration by parts. U times V, that's simple enough, minus 1/10 W squared cosine 10W. Yep. Okay. Now, remember a problem a while back, folks, made a big deal about that minus sign? Here's what I made a big deal about. Okay. Minus from my formula. Yep. So minus integral of V du. So integral of V du. Okay. So I've got a 2W times a minus 1/10 cosine. Yep. Number's what? Number's going to be a minus 1/5, right? I'm going to take that 1/5, minus 1/5, and factor it out just because it's a little bit easier to write down. But when I factor it out, that minus sign becomes, be careful with this, yeah, different color. That's positive, yeah, okay? So this is where you want to pay attention to minus signs. You see the minus sign here, you see the minus sign here, you're tempted just to write one minus sign down, okay? Minus sign, the black one sitting right there, and one sitting right there. Yeah. But it's easy to see two of them, write one down. Yeah. Okay, so pay attention to what you're doing, all right? Got my 1/5 there then, and then integral of what's left over. I still got my w from the u, so first from the du, I mean. Finally got something from the du left over other than the number, and then I still got my cosine sitting over here. Yep. So cosine of 10w. There we go. dw. Okay. So again, does everyone agree with my ability to write down a formula? That's all I've done at this point. Yep. Okay, everybody follow. So, what's the deal here at this stage? So, how have I been doing these again? I've been saying what? The idea is can I take an integral that I can't do, that one there that I underlined, and write it in terms of another integral that hopefully we can do? Yeah, with basic calc knowledge, I can't do this integral, can I? It's the same problem I've been dealing with all along. So by basic calc knowledge, I mean calc 1, yeah? Every integral I've done to this point, I should say every, but the previous two I've done, this integral here, second one that we wrote down, always came down to a Calc 1 integral. Yeah. Okay. Now, what I don't want y'all to get the idea down, folks, is that it will always do that. Okay. This is the right U and V pickup here. The problem is to finish this problem out, what do I have to do? I got to do integration by parts again. Okay. I can chain this thing up as often as I want to, folks. I can make you do integration by parts 20 times if I wanted to. I wouldn't, but I could. Right? So don't always expect these things to be straight up one and done. Sometimes you'll have to do more than one. Right? Be looking for that. Now, not hard. Okay. At this point, I don't want to say ignore everything done up here, but I got to reuse my letters again. So kind of ignore what I've done up here. So I'm just going to kind of scroll out of the way here. I'm just doing, in fact, let's do it this way. I'm just doing the green. Green. Oh, come on. Just green. There we go. Let's just do green. Yeah, so do everything in terms of green. So U, same thing. Let's just let U be the W here. Makes sense to do that, I think. So DU is going to be just a DW. And then we can let DV be the cosine. So cosine 10W dW. Integrate that. We'll pick up a 1/10 from that. Yeah, so 1/10 there. Integrate to a plus sign. And then 10W. Yeah. Okay. So, do y'all agree with that quick little work there? All right, now, these are where these problems get unpleasant, folks. I'm going to do a bunch of colors here if I can. So, we can equal sign over here. I've got that first term sitting there. I'm going to kind of leave this in black because it was always in black to kind of make sure where everything's coming from. Okay, I've got my plus sign there. I've got my 1/5 there. Yep. Now, I'm going to integrate this one by parts. Okay, so what do I have? So U times V, well, that's 1/10 W times the sign. Let me write a little bit easier for me. So 10 over W, save me a little bit of space here, times sine 10W minus integral of V du. Well, okay, 1/10, I'll factor that out of my integral. And then sine 10W dW left over. Everybody agree with the green part of things, yeah? So this bit here, with that bit there, yeah? Everybody agree with my, again, use of my formulas there, yeah? Would anybody like, again, to tell me what my mistake is? No, actually that's bad penmanship on my part. I'm not sure. Yeah, the W over, which one? Yeah, not sure. Potentially, oh, this one right here. Yeah. Sorry, no, that's just bad penmanship on my part. Sorry about that. That's just 10. So, yeah, that wasn't the mistake I was talking about, though. That's just bad penmanship. Sorry. You guys will get used to my bad penmanship. I like to say it'll get better, but it ain't. I'm too old. So, ain't gonna change. Not my mistake. Parentheses. Yeah, good. So I'm running out of colors here. Let's do blue there. It's 1/5 times the integral. Yeah. Okay. So it needs to be 1/5 times the integral. Yep. Okay. Watch your parentheses there, folks. Boy, this is one of the biggest mistakes folks make on this thing. Okay, the parentheses. Okay. You don't need to write them down, but if you don't, you need to make sure that 1/5 gets distributed all the way through. Okay. And so kind of we talked about a minute ago with that previous problem. I am only going to do that. Excuse me. I am only going to distribute it through if it's going to make it easier to write. In this case, it ain't going to make it easier to write. Yep. This one, Courtney, that's a DW because it's coming in from the W, all this stuff up here. So DW. Oh, this one here. Yeah. Still. Oh, this one here. I see. Yeah. I'm sorry. Getting close to the end of time. I apologize for that, folks. Getting a little bit of a hurry. So again, as always, pay attention. Don't get too much of a hurry. Yep. Okay. And in fact, we're pretty much done here, folks. Let me just add one more thing on at this point, so we don't forget about it. Oops, I'm not quite done. Sorry about that, folks. Finish that real quickly here. Okay. I am done because I can do this integral now. Yep. Okay, so let me kind of crank through this real quick. I'm kind of pretty much out of time here. So minus w squared over 10, so I can kind of shorten things up here a little bit. 10w, okay? Plus my 1/5, again, I'm gonna leave my parentheses. You could distribute it through if you wanted to. Nothing wrong with that, but I'm just gonna leave parentheses there. Okay? Minus integral sine, what is that? Minus cosine, yeah. So plus cosine, 10w. I've got a 1/10 already here. I'm going to pick up another 1/10 for my substitution, so a 1 over 100. Yep. 1/10 I've got, plus the 1/10 for my substitution. I did the integral, close my bracket off, and now my ever present plus c. Okay. Okay. This makes sense to everybody. Hopefully. Yep. All right. I know this last problem got a little bit rushed here, folks. I held you up about a minute late. I apologize for that. I try not to do that, but I wanted to finish this one out. You could probably get a little bit started on the homework if you wanted to at this point, folks. Look at it real quick. You can do numbers 1 and number 2. That's it. Don't attempt anything else on the homework. Okay. I will get you going on the rest of the homework tomorrow. Okay. So there it is, folks. We'll stop it here today. You're free to go at this point. Again, if I need to, as far as attendance for tomorrow, I will send an email out, but I don't think I'm probably going to need to. But we'll be looking for it tonight or tomorrow. Okay. So I will see you all tomorrow.